recap of what you know about fractions. Okay, number one, when you have a number divided by itself, it will result in 1. When you do 0 divided by anything, the result is 0. When you have anything divided by 0, what happens? It doesn't work, and then we write that the number is undefined. Okay, when you add or subtract fractions, what's the big idea? Do you remember? What do you need when you have an adding or subtracting fractions? What's the only way to do that? You need a common denominator. So that means I have a 2 and a 4, and I'm trying to think of a number that would work. So the number I would pick would be 4. I could turn them both into a 4. Okay, so how would I turn this into a 4? I'm going to have to times it by 2, which means the top is going to get the same. So 2 over 4. This, nothing. It's just the same. So 5/4 is the answer. Okay, is it kind of coming back, some of that stuff? Okay, I'm going to skip the next one because it's the same. Okay, this one, I need to pick a number that I can turn them both into. So a 3 and a 4, what could I change them both to? 12. So how did I change this 3 to a 12? Times it by 4, which means the top would become an 8. How did I change this 4 to 12? Times by 3. So now the top will become a 3. So 11/12. Okay, so common denominator. That's the big idea. Okay, next is timesing. So if I really wanted to understand timesing, I really could just do this. I'm not going to, but we'll write it down here. I really could just times the top and times the bottom. That's how fractions work. You could do that. But if I'm asking you to reduce it, you could start trying to reduce this, but I'm going to actually do something easier. I'm going to reduce before. So, do I see anything from the top and the bottom that are divisible by the same number? 6 and 18 could both be divided by 6, right? They could be divided by 3 as well, but I'm going to try to pick the biggest. So I'm going to divide these by 6. So if I do that, that would turn into a 1. And if I divide this by 6, it would turn into a 3. Now, oh, I'm looking at 14 and 7. I could divide those both by 7. So 14 divided by 7 would turn into a 2. 7 would turn into a 1. So this would turn into 2/3. And you could have got there with the long way, but I'm guessing no one could probably see that I could divide both of that by 42. 84 divided by 42 is 2. 126 divided by 42 is 3, and that's how it could reduce. Okay, but it's way easier to reduce with small numbers. Okay, what's the big idea when you divide fractions? Remember the big idea when you divide fractions? Multiply and flip. Okay, dividing by 2/10 is the same math as timesing by 2/10. So I could go 48 over 50, I could write that, but I'm going to look for stuff that reduces first. Can I divide any top numbers and bottom numbers by something that's the same? I think I could do a 24 and a 10, both divisible by 2. Or 2 and 10, both divisible by 2, doesn't matter. Okay, so if I divide by 2, this would turn into a 12. 10 divided by 2 would turn into a 5. And now the top is 24 and the bottom is 25 because I'm just doing 12 times 2. 5 times a 5. Okay. What do you think? Should we do one more? Let's do the next one, I guess. Okay. What is going on with this? I have a subtraction and a multiply. So bed mass tells me what? Do that first, right? Okay, so I don't know, I'm just going to make this a little bigger for myself. What can I cross off on a top and a bottom here? So 14 and 7, top and bottom, that could turn into a divide by 7 is 2, divide by 7 is 1. 3 and 15, I could divide those both by 3, turning this into a 1 and a 5. So that all would come into be a 2 over 5. Okay, now I'm going to do the subtraction. Okay, so now putting these together, I have to do a common denominator. So I want both of them, I think, to be a 10. So 9/10. And then this would have to turn into a 10 by doubling. So 9 subtract 4 is 5/10, which is also a reduction of a half. Okay, and then you've learned this somewhere. This is called a mixed fraction because it has a whole part and a mixed, or whole part and a partial part. Okay, so think about your pies getting cut into 9ths. If you have 2 entire pies with 9 slices, that's already 18 slices. And then in your last pie, you have 2 more slices. So that's 20 slices of 9ths. Okay, so it's kind of like times and add. Okay, so now improper to mixed, how many 3s can you fit into 17? without going over, how many can you fit in? 5. I can get 5 holes in there. So that's 15, which means how many leftovers do I have to get to 17? 2. Okay, so 15 plus 2.